Hello everyone, in this video we'll solve this interesting math question. Here is natural log y, ln y is equal to a sin inverse x, and we'll find out if I do, here is derivative of 2 times, and we'll find out here is 1 minus x squared y2 minus x y1 minus s squared y is equal to 0. I do derivative this question in 2 times. So let's start. Our question is ln y is equal to a sin inverse x. So if I want to solve this question, we need some formula. First of all, I can say and know that e to the power ln a is equal to a. This is our first formula. If I want to solve this question, we know that e to the power ln a is equal to a. And again, we know that derivative of sin inverse x is equal to 1 over square root 1 minus x squared. And again, I can say other formula, we know that e to the power, derivative of ub, it will be u derivative of b plus b derivative of u. And again, we know that derivative of e to the power x is equal to e to the power x. And at this moment, if I solve this question, our question is ln y is equal to a sin inverse x. Then if I use both sides e, this time I can say e to the power ln y is equal to e to the power a sin inverse x. Then we know that e to the power ln a is equal to a. So according to this source, I can see easily here is e to the power ln y is equal to y is equal to, here is e to the power a sin inverse x. Then at this moment, I use both side derivative. So if I do derivative both sides, this time I can say derivative of y, it will be y1. Derivative of y, it will be dy by dx, it will be y1. And here is e to the power a sin inverse x. We know that derivative of e to the power x, it will be e to the power x. So I can say easily here is derivative of e to the power a sin inverse x, it will be e to the power a sin inverse x. There is no change. But again, if I do, here is a sin inverse x. If I do derivative, here is a sin inverse x. This time I can say here is a is constant, and derivative of sin inverse x, it will be 1 over square root 1 minus x squared. Then this equation becomes, I can see easily, here is y1 is equal to, here is square root 1 minus x squared, and here is e to the power a sin inverse x, and here is a. Then if I multiply both sides square root 1 minus x squared, this time I can say it will be square root 1 minus x squared times y1 is equal to a, this a, and here is e to the power a sin inverse x. I multiply both sides square root 1 minus x squared. And in this case, I can say easily, here is, look, square root 1 minus x squared times y1 is equal to ay. Because of that, we know that, look, here is e to the power a sin inverse x, it will be y. So I can say here is a, and here is e to the power a sin inverse x, it will be y. Then At this moment, if I want to move on this square root, I use both side whole square. So I can say here is whole square and here is whole square. So at this moment, I can see easily it will be square root is cancel. So 1 minus x square times y1 square is equal to s square. Here is y square. Then if I do again derivative, if I use both side derivative, this time I can say here is u and this is v. So we know that ub, it will be derivative of u. We know that u, here is u is 1 minus x square, derivative of y1 square plus y1 square, derivative of, I use uv rules, and here is 1 minus x square, and here is a square is constant, so I can say here is a square, and y square, it will be derivative of y square. Then in this case, look, here is 1 minus x square, so 1 minus x square times y1 square. I can see easily, according to power rules, derivative of x to the power n is equal to n x to the power n minus 1. According to these rules, I can say it will be 2 y1, and again if I do factorization, again if I do derivative y1, so it will be y2 plus, and here is, look, y1 square, and we know that derivative of 1, it will be 0, and derivative of minus x square, it will be minus twice x is equal to a square, and derivative of y square, it will be 2y y1. Then in this case, I can see easily, here is 1 minus x square, and here is 2 y1 y2 minus, because of that plus minus, it will be minus, and I can say here is 2x y1 square, and here is minus. I just move on this term in left side, here is positive, we'll find out in this case negative, so it will be a square 2y y1 is equal to 0. Then in this case, I can say here is 2y1 is common, so here is 2y1 is common, so in this case I can say here is 1 minus x square, and here is y2 minus x y1, because of that here is 2y1 is common, minus, it will be a square y2 y1 is common. I mean, I divide every value by 2y1, and here is 0. Then if I divide both sides 2y1, so 2y1 cancel, we'll find out here is 1 minus x square, and here is y2 minus x y1 minus s square y is equal to 0. This is our final answer.